Welcome to 6.3 and 6.4 extra practice in Unit 6 Quadrilaterals. In number 1 through 6, we are asked to complete each statement using the words parallelogram, rectangle, rhombus, and square. A piece of advice for this section is think back to the flow chart that we had on the board and in our notes. Every rectangle is also a blank. Every rectangle is under the umbrella of quadrilaterals, but more specifically, every rectangle is a type of parallelogram. Every rhombus is also, well, not only is it a quadrilateral, but it also falls under the umbrella of parallelogram. Number 3, every square is also a blank, and a blank. Every square is also a parallelogram. It's also a rectangle, and it's also a rhombus. Number 4, a parallelogram with congruent diagonals. That is a trait of a rectangle and also a square. Number 5, a parallelogram with diagonals that are perpendicular is by definition a rhombus and also a square. Number 6, a parallelogram whose diagonals bisect the opposite angle is a rhombus or a square. That concludes section 1, which covers questions 1 through 6. Question 7 says the properties that a rhombus and a rectangle have in common are. They have in common all of the properties of parallelograms. We talked about the 7 properties of parallelograms. Opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Diagonals bisect each other. Consecutive angles are supplementary. One diagonal makes a pair of congruent triangles. And one pair of opposite sides are both congruent and parallel. Question number 8 asks for 3 properties of a rhombus that are not properties of every parallelogram. So in this question, they're really asking us what makes a rhombus special. And there are 3 things about a rhombus that makes a rhombus special. Number 1, all sides are congruent. In a rhombus, all 4 sides are the same length. Number 2, the diagonals are perpendicular, meaning they create 90-degree angles. And number 3, the diagonals bisect the opposite angles. That means that as the diagonal comes into the corner of a rhombus, it cuts that corner into 2 equal angles. Question number 9 says 3 properties of a square that are not properties of every rectangle. So we know that all rectangles have 4 90-degree angles, but what makes a square different than a rectangle? All 4 sides are congruent. The diagonals are perpendicular. Remember, a square is also a type of rhombus. And number 3, diagonals bisect opposite angles. Again, all squares are both rectangles and rhombi. Question number 10, 2 properties of a square that are not properties of every rhombus. So what makes a square different than a rhombus? First of all, a square has 4 right angles. And number 2, just like it is with a rectangle, the diagonals are congruent. That concludes 7 through 10. Now, looking at question number 11. It says, VWXY is a rhombus. WZ equals 5 and VZ equals 12. The first thing I'm going to do is, because it is a rhombus, I am going to mark on my paper that these angles are 90 degrees. The the diagonals bisect opposite angles and are perpendicular to one another. We're also told that WZ is 5 and VZ is 12. Most of you are looking at this now, and I hope that you see that we do have a right triangle. We have that right triangle right there. So I know that right triangles have the Pythagorean theorem, that a squared plus b squared equals c squared, where c is the hypotenuse. Well, that's what I'm trying to find. I'm trying to find the hypotenuse. So I will call this side, since it's the hypotenuse, I will call it c. A and b can be either of the two legs. So 12 squared plus 5 squared equals c squared, where c is the length of VW. 12 squared means 12 times 12, which is 144. 5 squared is 5 times 5, which is 25, equals c squared. 144 plus 25 is 169, equals c squared. And I hope that you are all watching this video and smiling a little bit, because 169 is a very special number called a perfect square. 169 is the perfect square of 13. So when I square root both sides, I find out that 13 equals c. And there is my answer. C is 13. So VW is 13. That is question number 11. Question number 12 tells me ADBC is a rectangle. So first of all, because I know it's a rectangle, I know this. These are all 90-degree angles. We're told that AB, the distance from A to B, the distance from A to B is 5. A to D is 4. And we want to find DB. So again, I hope you're looking at this and seeing the right triangle. Right there. And again, I'm going to do a squared plus b squared equals c squared. A squared plus b squared equals c squared. This one is a little different in the fact that I know the hypotenuse. I know 5 is my c. So I will call this side A. Squaring my legs, a squared plus 4 squared equals 5 squared. A squared plus 16 equals 25. Subtract 16 on both sides. A squared is equal to 9, and the square root of 9 is 3. So DB's length is 3. Some of you may be sitting and thinking, and I hope you are, that when you see 4 squared and 5 squared, that you remember that one of our special right triangles is a 3, 4, 5 triangle. If you saw that, you were able to skip the step of showing all of the Pythagorean theorem. On the back, questions 13 through 16 say find the value of the variable. Question 13 says the figure is a rhombus. One thing that I know about all rhombi is all sides are the same length. So because all four sides are congruent, I can choose any two to set equal. 5x plus 11 will be set equal to 32. Subtract 11 on both sides. X equals 21. I'll then divide both sides by 5. And I will get x to equal 21/5, which does not reduce, but I can write that as a decimal if I would like, as 4.2. Either the improper fraction 21/5 or the decimal 4.2 would be sufficient. Question 14 says that IJKL is a rectangle, and the measure of angle K is 10y minus 5 degrees. Remember what we know about all rectangles? All angles are 90 degrees. They are all 90-degree angles, which means 10y minus 5 equals 90. I will add 5 to both sides. So 10y equals 95. We'll then divide both sides by 10. And y equals 95 divided by 10. That does look like it is divisible by 5, so the top would be 19/2, which would be 9.5. 9.5 for the answer to question 14. Moving on to question 15. Quadrilateral MNOP is a rhombus. Measure of angle M is 5z plus 10, and the measure of angle P is 8z plus 14. For question number 15, I need to know, just like all parallelograms, consecutive angles are supplementary, meaning angle M plus angle P will equal 180 degrees. 5z plus 10 plus 8z plus 14 has to equal 180 degrees. That's what supplementary means. Combine like terms on the left side. 5z plus 8z is 13z. 10 plus 14 is 24. And it is still equal to 180. We will subtract 24 on both sides. $13z is equal to 156. Divide both sides by 13. And z is equal to 156 over 13, which is the improper fraction. Which is 12. When I divide it out, it divides out to 12. And lastly, question number 16. Question number 16 says quadrilateral STUR is a rhombus. And the measure of angle T is 6A minus 29, and the measure of angle R is 4A minus 3. Just like all parallelograms, a rhombus has opposite angles that are congruent. So these two angles are congruent. So I can take 6A minus 29 and set it equal to 4A minus 3. I'll get my A's on the same side by subtracting 4A on both sides. So 6A minus 4A is 2A. Oh, 2A minus 29 equals negative 3. I'll add 29 to both sides. And find that 2A is equal to 26. And lastly, divide by 2 on both sides. And I get A to equal 26 divided by 2, which is 13. That concludes our work today, and I hope you enjoyed yourselves.